There are many definitions of sustainability. Here at SemCorp, sustainability is safeguarding the future. To us, that future is bright. We harness the power of the sun and wind, design low-carbon sustainable solutions for green urban cities, and lay the foundation for generations to come. Sustainability is innovation, challenging the norms and leading disruption. We innovate to solve complex global problems. We use our experiences to create opportunities from challenges. Sustainability is about the communities. We care for the communities and aim to improve their quality of life. We forge strong partnerships and leverage our platforms in the region to deliver sustainable solutions. Our success is founded upon the trust from the communities we serve. Sustainability is about our people. Our success is bolstered by the strength and energy of one SemCorp team, a team that can thrive in the current and future world. Sustainability is not just a catchphrase. To us, sustainability is our business.
Good morning, good evening, everybody. Thank you for joining us today. We'll be officially starting our US-ASEAN Energy and Innovation Forum right now. My name is Christian Koshiel. I'm a commercial officer with the US Department of Commerce based out of the US Embassy in Singapore, and I'll be your moderator today. Before introducing our speakers, I'll briefly review today's agenda. We'll have roughly 1 hour of presentations. We'll jump into a 30-minute roundtable style Q&A session, and then we'll conclude. Just to warm up and get that nice global feel for today's event, please use the events chat box on the bottom right of your screens to type in where you're joining us from. You may be wondering why do this exercise. It's not just a warm up, but rather it's important since for the Q&A session later on at the roundtable, I'll look forward to looking at that Q&A for questions from you to engage with our presenters today. With that, let me introduce our first speaker. Rich Stephens is the U.S. Department of Commerce's Acting Deputy Assistant Secretary for Asia. Prior to his assignment in Asia, Mr. Stephens served as Deputy Assistant Secretary and Executive Director for Western Hemisphere, where he managed Commerce's negotiating teams working on the U.S.-Mexico-Canada Agreement, also known as USMCA. Rich, the Zoom floor is yours.
There. I hope everyone can hear me. Am I good? All right, excellent. We have people tuning in from the US, Singapore, and across Southeast Asia and the Indo-Pacific. Let me welcome all the industry and government representatives tuning in. Let me thank my co-panelists, Jonathan Goh, Singapore's Energy Market Authority, Bloom Energy, the Electric Power Research Institute, and Durapower Asia. Today's discussions will provide a look at innovative areas of clean energy technology that are driving the world closer to achieving climate goals. The Biden administration understands the pressing nature of addressing the global climate crisis. Immediately after assuming office, the president signed the instrument to bring the US back into the Paris Climate Accords. He reaffirmed the US commitment to promoting greater climate ambition throughout the world and reducing global greenhouse gas emissions during the Climate Leaders Summit. The US has committed to reduce greenhouse gas emissions between 50 and 52% below 2005 levels by 2030. We believe this goal is ambitious but realistic. Reaching these goals will take a wholesale transformation of the global economy. With many countries in the Indo-Pacific particularly vulnerable to the negative impacts of climate change and with growing demand for energy, the need for innovative clean energy and technology solutions is significant. The success of markets in the Indo-Pacific region will depend on leadership from the private sector, including manufacturers, investors, innovators. U.S. industry is well positioned to meet the region's urgent energy and climate needs. Our companies draw from decades of experience and lessons learned in addressing environmental challenges and have a proven track record of innovation. This includes leading cutting-edge research and development, advanced manufacturing of renewable energy equipment, and mobilization of private capital to drive investment. Whether it's hydrogen, carbon capture, smart grid, or others, innovative U.S. clean tech companies are ready to do business. At Commerce, we tackle the climate crisis head-on. We connect innovative U.S. clean tech companies to help solve the challenges in each market in the Indo-Pacific. We are achieving this in several ways. We are deepening our engagement and promoting greater collaboration on clean tech through such mechanisms as the U.S.-Japan Clean Energy Partnership. In addition, earlier this month, Secretary of Commerce Raimondo and Singapore Minister for Trade and Industry Gan signed a memorandum of understanding to implement the U.S.-Singapore Partnership for Growth and Innovation. This partnership will strengthen the U.S.-Singapore relationship with an emphasis on clean energy and climate change solutions. Commerce is working with colleagues throughout the U.S. government to launch a U.S.-Singapore climate partnership, which Vice President Harris announced during her trip to Singapore last August. Through the partnership, the U.S. and Singapore will work together to develop high-quality climate standards. Through these engagements, we aim to deepen our collaboration with markets across the Indo-Pacific to find solutions to climate change challenges. We are going to hear shortly from U.S. and Singaporean energy stakeholders. Bloom Energy, the Electric Power Research Institute, and Durapower are pushing the conversation forward in deploying innovative clean tech technologies, including fuel cell tech and energy storage systems, in order to create greener and more flexible power systems. If you are interested in learning more about Commerce's clean energy technology initiatives in the Indo-Pacific, my Asia team will be very happy to facilitate a follow-up. And for those who want to follow up with me, my email address is richard.steffens@trade.gov. The last name is spelled Steffens. Welcome hearing from you.
Thanks so much, Rich. Really appreciate that. Just as you mentioned, we'd be happy to connect after today's event. Now let me introduce Mr. Jonathan Goh. Jonathan Goh has served as Director of External Relations at Singapore's Energy Market Authority, EMA, for 9 years, and we've had the honor of working closely together on several rounds of Singapore International Energy Week. Jonathan manages intergovernment energy cooperation and organizes the SEW. Director Goh, the Zoom floor is yours.
Thank you, Christian. And good evening from Singapore, and good morning to all of you in the United States. Richard Steffens, Deputy Assistant Secretary for Asia, United States Department of Commerce. Excellencies, distinguished guests, ladies and gentlemen. I'd first like to thank you for joining us here today at this Thinktank Roundtable held at the sidelines of the 14th Singapore International Energy Week, or SEW. I would also like to thank the United States Department of Commerce for hosting this roundtable today. Last year, we held the inaugural ASEAN-US Energy Storage Forum at SEW 2020, and this year we are very pleased to welcome once again the Department of Commerce. The topic of this year's roundtable, ASEAN-US Energy and Innovation Forum, is aligned with the discussions throughout SEW 2021. Now this year, advancing the energy transition reflects the opportunities and challenges the energy transition presents in the post-COVID-19 environment. Over the past few days, ministers and industry leaders discussed the importance of innovation in accelerating energy transitions. This roundtable will complement the discussions this week by showcasing the US perspectives to innovative energy solutions and technologies. This will help to contribute towards addressing our clean energy and climate priorities. As mentioned by the Secretary, now during the US Vice President Kamala Harris' state visit to Singapore in August this year, our Prime Minister Lee Hsien Loong and Vice President Harris jointly announced the launch of the US-Singapore Climate Partnership. This partnership will foster closer collaboration on climate action, environmental governance, sustainable development, and low-carbon solutions. We welcome the US interest to deepen collaboration and share expertise on the latest energy technologies and solutions available to accelerate the pace of transition. We appreciate the closer partnership between Singapore's Ministry of Trade and Industry and the United States Department of Commerce. Singapore's energy transition announced earlier this week outlines our energy priorities moving forward. We will optimize the 4 switches of natural gas, solar, regional power grids, and low-carbon energy technologies such as hydrogen and carbon capture utilization and storage, or CCUS. The role of innovation in our energy transition is key. Now, last year, we launched the Singapore $49 million Low-Carbon Energy Research Funding Initiative. This aims to provide and develop promising solutions to decarbonize the power and industry sectors. Now, this year, we will continue to explore innovative ways to increase renewable energy deployment, such as floating solar and energy storage systems. We will be awarding Singapore $55 million to research projects focused on improving the technical and economic feasibilities of low-carbon technologies. Now, EMA is also working with the industry to explore the use of hydrogen-enriched natural gas as the fuel at existing power plants, as well as the import of low-carbon hydrogen. Our 4 switches offer significant opportunities for innovation. This will support the development of these technologies and decarbonization of the power and industry sectors. It also offers a great opportunity for Singapore and the United States, and also for countries in the region, to further enhance regional energy cooperation. As a country coordinator for ASEAN-US energy cooperation, Singapore works very closely with the United States to deepen regional energy cooperation across various issues. Now, this includes investments, financing, and clean energy technologies. The EMA and the US Department of State and the Department of Energy successfully organized the ASEAN-US workshop on decarbonization of the energy sector earlier this year. These extensive discussions on the role of hydrogen and energy storage systems are very relevant and insightful. Now, at the 39th ASEAN Ministers of Energy meeting of AMEM last month, we held the inaugural AMEM-US Ministerial Exchange to further our cooperation exchange. The US Secretary of Energy, Jennifer Granholm, outlined various US and clean energy initiatives. The Secretary also called for strong exchanges to accelerate the deployment of clean energy technologies in ASEAN. Under the ASEAN-US Energy Cooperation Work Plan of 2021 to 2025, we will sustain areas of engagement in the areas of energy security and resilience, renewable, advanced and emerging technologies, energy market integration, and natural gas and petroleum. We hope that in 2022, ASEAN and the United States will be able to have further opportunities of collaboration. To conclude, the forum today, and the Thinktank Roundtable today will showcase innovative solutions to enhance the deployment of clean energy. We look forward to hearing from all the energy experts, industrial partners, in fuel cell technologies, energy storage system, and innovative solar technologies. We hope this will further facilitate greater discussions on innovation going forward. I wish everyone a fruitful discussion ahead. Thank you.
Thank you, Director Goh. I'm certain we'll be able to advance US-Singapore economic cooperation in 2022. Now let's move on to our company presentations. Up first is Benjamin Kasinski, Director of Business Development for Bloom Energy. Benjamin, the floor is yours.
Thank you, Christian. Thank you, Jonathan. Thank you, Richard, for your introduction remarks. And good morning and good evening for everybody. So I'm Ben, Director of Business Development for Bloom Energy, based out of Malaysia and looking after whole of Southeast Asia for Bloom Energy. You can change the slide, please. Thank you. Bloom Energy at a glance. Bloom Energy is San Jose, California-based company with manufacturing facilities both in California and in Delaware. We are a world leader in solid oxide technology, fuel cells, and electrolyzer cells. Today, Bloom Energy has installed more than 600 megawatt of capacity in the world, scattered around 700 sites, mainly out of the US, South Korea, India, and Japan. Today, the company is about 1,500 employees in the US and in the world. 2021 saw a massive move in international expansion for Bloom as international headquarters were started up in Dubai. And we are looking from there to expand Bloom Energy in a lot of different regions, amongst which Southeast Asia is on the top of the list. Next slide, please. Bloom Energy caters for a platform out of solid oxide that today runs on natural gas or biogas, but has a clear path to net zero carbon emission requirements of our customer through the addition of hydrogen in the blend. Today, Bloom Energy can cater up to 50% of hydrogen blending with natural gas or biogas, and tomorrow, Bloom Energy fuel cell will be working 100% on hydrogen. This is actually already the case, as a 100 kilowatt fuel cell is being tested right now in South Korea, solely being fueled on hydrogen as a byproduct from an industrial facility. Next, please. The technology platform of Bloom as a solid oxide plate is not rocket science, even though it was developed in a NASA Mission to Mars program 20 years ago by our CEO, Kaya Shredder. It's a very simple electrochemical reaction from hydrogen and on the green plate, which we call anode, and oxygen on the gray plate, which we call the cathode. That reaction produces an electrochemical reaction and a differential of potential, creating electricity on the output. On the inside, we do have a steam reformation process that breaks methane, which is the main composition of natural gas and biogas, into CO2 and H2. That H2 is used at the plate and the CO2 is expelled in the atmosphere. The system of Bloom comes as a unit of 250 to 300 kilowatt. We can add multiple systems to reach megawatts or even gigawatts of capacity. The unicity of Bloom's system amongst the scalability of those bricks that you can combine together is the amazing efficiency that we have on the system. We start from 65% down to 53% over the lifetime of the product. But nonetheless, we still maintain a highest efficiency in the market of fuel cell, thanks to the fact that the exothermic reaction at the plate creates heat, which is used for the steam reformation process at the beginning of the fuel cell process. The natural gas being not going through any combustion does not emit any particle, NOx, SOx, or any other pollutants other than CO2. And that CO2 is limited to 800 pounds per megawatt hour, or an equivalent to 340 kilos. As a comparison, the Singaporean grid emission factor is about 410. Next, please. Our platform would cater resilient microgrids or a grid parallel solution where the Bloom Energy server can provide power directly in grid parallel mode, where you see on the dotted line, it will come in parallel to utility grid to solar, providing resilient power and affordable power to all kinds of loads. But we also have the possibility to work as a microgrid solution where the Bloom Energy Server would maintain a certain level of power for critical loads through special and dedicated microgrid inverters. Bind to carbon-free sources of fuel, whether it's renewable hydrogen or whether it's natural gas or biogas combined with carbon capture, or it's on-site directed renewable biogas. This whole combination of Bloom and carbon-free fuel will deliver clean, sustainable, and carbon-free power to our customers. Next, please. Bloom today, as I mentioned in introduction, has more than 600 megawatt capacity installed in the world. Most of those capacity are installed in the US, on the West Coast and on the East Coast, primarily due to a lack of resiliency of the grids there from weather events or any power outages. We have been deploying bigger capacity outside of the US and South Korea, thanks to the very friendly environment created by the government promoting both hydrogen economy and fuel cell economies. New developments are being carried out in Japan, in India, and throughout the world. Demand customers today of Bloom are obviously utilities, but we do power retail and media and telecom, and also a big portion of our customers are data centers that are requiring critical power application, which Bloom covers for them. Next. As you see, and as I just touch up on the previous slide, some of the big names have been trusting Bloom for their critical power or grid parallel application. Whether we are in a cloud service and technology, the names of Google, Equinix, for example, have been following Bloom for almost a decade. Delaware Power in Delaware is one of the biggest utility installation we have. It's close to 30 megawatt. And we are expanding in consumer, retail, financial services, healthcare, and industrial facilities in the world, especially providing path to carbon reduction to heavy carbon emission industries such as oil and gas, mining, or steel manufacturing. Next, please. One of the picture of one of the biggest installation we have in Orion to date, it's close to 20 megawatts in Pasung in South Korea. You see, it doesn't take much space. It's very clean, it's very neat. What you see on the top of the Bloom Energy Server is the little exhaust. That exhaust expels the CO2 at ambient temperature plus 20 degrees in case it's not needed to have a specific dedicated waste heat recovery, but we do have the ability to recover the heat that comes out of the fuel cell, which at normal temperature, original temperature is about 350 degrees C. That will allow for waste heat recovery to be transferred into heat or into cooling through vapor absorption machine, enhancing the efficiency, but also reducing the overall carbon footprint of the installation. Next, please. The Bloom Energy Server has a density of more than, reduces the density of almost 12,500% compared to solar power plant. So in constrained environments such as Singapore, this form of energy would be a very interesting way forward, as it condenses the power production and provides a stable baseload type of production in very constrained space. In more even constrained space environment, power tower can be designed, stacking the fuel cells in 2, 3, or 4 floors, providing an even higher density of power in reduced space. These power towers are mainly dedicated to data center application or utility application. It also has a much better environment to collect the waste heat and have a cogeneration process in place. Next, please. The fuel cell as a platform can be used in a reverse mode. because the electrolyte plate is actually the same, whether we use the fuel cell to produce electricity from the hydrogen that has been produced earlier on, either in a steam reformation process internally, or if we have an access to hydrogen production externally. But reversing the mode of flow inside of the fuel cell, we will produce hydrogen from electricity and steam. Next, please. In that sense, in a way to integrate the different elements of Bloom, whereby we have the Bloom energy server that will be fed with different sources of green fuel, landfill to biogas, or any green hydrogen, or even carbon capture, allowing the Bloom energy server to deliver net zero energy. Third-party DC would be as well converted to the bus, and an energy storage module being developed as well will have the third leg of complete system, allowing Bloom to deliver resilient, clean, and sustainable power to a lot of different interfaces, requiring such stability and sustainable energy. Next, please. The carbon is today what everybody is chasing after to get rid, and hydrogen is one of the best solutions we've found so far as an integration to the electrical grid, whether it's for the generation of hydrogen through electrolyzer, or through production from hydrogen to produce electricity. That hydrogen will be used either for transportation, for synthetic fuels, or the upgrade of oil or biomass plants, but also in chemical industry, in metal production, or even in heat or distributed power. To produce that hydrogen, we need energy, and that energy will bring a color to the hydrogen. Whether it's renewable, clean, it will deliver green hydrogen, whether it's nuclear or any other form of energy, the hydrogen will have different color. We'll see that on the next slide. Next, please. Through its solid oxide electrolyzer cell or solid oxide fuel cell is present in the whole supply chain of the energy transformation from hydrogen. In a stationary mode, whether it is from natural gas or from biogas with carbon capture and underground storage and sequestration, we can produce green hydrogen or gold hydrogen that allows us to deliver net zero energy to our customer. Hydrogen from nuclear power plant power and excess steam will produce pink hydrogen. In that sphere, we are discussing and have signed a partnership with the Idaho National Lab in the US to promote and to develop nuclear-powered electrolyzer cells, but also green hydrogen. Green hydrogen from renewable energy be one of the best future source of hydrogen production, and a lot of supply chain issues are being dealt with to cater for this transportation of hydrogen. In transportation environment, whether it's land or sea, the Bloom hydrogen electrolyzer or fuel cell will also be used in fuel cell fed vehicle directly or in a charging station. We also have developed a power system with Samsung to power vessels for ship lines and bunkering vessels. Next, please. In the whole application, fuel cell and electrolyzer can be found pretty much everywhere in that net zero carbon economy. Whether we use nuclear power, renewable power to create hydrogen, to then push that hydrogen for storage or for blend in pipeline with natural gas, or for a new dedicated infrastructure of hydrogen pipelines, we will have the ability to keep providing resilient, sustainable, and affordable power to critical loads or non-critical loads to our customer, as you see for the hospital at the bottom left, but also on-site production of hydrogen in steel mills or ammonia plants will be able to support the green ammonia or green steel production. Last but not least, distributed hydrogen production system will be allowing mobility, whether it's trucks for deliveries or forklifts in factory, or even personal vehicles. Bloom energy servers and Bloom electrolyzer cell will cater all the need for a sustainable future. Thank you.
Thank you so much, Ben. I see what an integrated solution that you've got there. It's really interesting. Up next is our second speaker, Dan Killeran, Program Leader for the Global Innovation Hub at the Electric Power Research Institute, or as we say, EPRI. Dan, the floor is yours.
Great. Thank you so much. It's a pleasure to be here. For those of you that aren't familiar with EPRI, we are a nonprofit research and development organization headquartered in the United States. Much of our funding comes from our membership of utilities, representing the vast majority of North American utilities, but also including members in nearly 40 countries. And we conduct research, objective research. We don't inform policy making or make policy recommendations. We don't manufacture any equipment. Our primary aim is to inform the future energy landscape through the work that we're doing. The piece of research that I wanted to share with you today is around a look that we did at standards around grid modernization in 5 Asian countries. The aim was to look at the current standards in place and where there might be opportunities to adopt additional or different standards, all with the aim of improving the interoperability of equipment on the grid. If you want to go to the next slide, you'll see here an overview of the objective of the study. You can see the countries that we focus this particular research on and specific ways in which smart grid standards could be adopted for the aim of improving performance and the benefits that can be achieved by many stakeholders with the greater integration of DERs. Next slide, please. This concept, I'm sure, is familiar to many of you, but just to really emphasize why grid modernization is so critical to the future energy landscape. As we just heard, the opportunity to integrate new technology onto the grid to decarbonize, increase resiliency and reliability is vast. And the technologies that will be incorporated in that future landscape are varied, meaning that the ways in which these technologies interface with one another is extremely critical to the future reliability and operation of the grids all over the world. Those technologies, as you can see there on the right-hand side of the slide, vary quite dramatically. But what we're also seeing is the drivers of this transition being not only decarbonization, which is a clear aim, but also the increase in extreme weather events and the impacts of climate change, posing new resiliency challenges to grids all around the world. We have several recent examples here in North America, and I'm sure others from around the world have witnessed these examples of how extreme weather events are presenting severe stress to the grid and its current configuration. With these new technologies, this can increase the resiliency, but would also emphasize, particularly in the regions we're talking about today, that rapid load growth is a significant factor and critical to the continued economic development of the countries that we're covering in this study. as in contrast to North America, where their rate of load growth, is not as robust, or in even certain regions flat to declining. That's not the case in the countries that we studied here, where I'll share later, we're seeing a very robust load growth in addition to increased adoption of DERs. We want to go to the next slide. I'll just touch on briefly why interoperability is so important. It really is to create that seamless interface of technology and devices that have to communicate and contribute to the electrical grid. So interoperability really is an enabler for technology. If technologies and applications are not able to seamlessly communicate, then the benefits of integration are vastly diminished and resulting in higher cost or a lower benefit in terms of the value to the grid. So one aspect of that is certainly the standards that manufacturers and others utilize in designing equipment to interface with the grid. And that gets to the point of the study that we looked at here around what are some of those standards currently in place and what might be some opportunities to adopt new or different standards. We want to go to the next slide. You can see here an overview of what the study actually entailed. The research involved compiling a comprehensive list of smart grid standards that were currently in place, looking at those in relation to what standards were in place in the 5 countries noted there on the slide, looking for opportunities for gaps, or just to note the change or the differences in standards that exist today, and then highlight a few priority standards to dig into a bit deeper to again see if those might be candidates to look at for the policymakers in these regions. Next slide. If you're not familiar, at the bottom of the slide here, you see the 4 main entities that are responsible for setting most of the standards that set the design of grids around the world. The study looked at over 59 standard families produced by 17 organizations, but the primary ones being the 4 that you see there listed on the bottom of the screen. Because DERs touch on so many different aspects of the electricity value chain, it really covered a wide swath of that, from transmission distribution to customer end use and applications like electric vehicles and other smart and grid connected technologies. Next slide, please. You see here an overview of the number of standards and organizations that were looked at. As I noted, those 59 different standards families and how they distribute across those 4 main standards bodies that I shared there earlier. You want to go to the next slide, please. So what we found in these 5 target countries, that was that all the national standards bodies in all these countries appear to accept only the standards produced by these international organizations. In Indonesia, Malaysia, and Philippines in particular, showing that ISO and IEC standards were accepted, but not finding support or use of the ANSI or IEEE standard families, which are more prevalent in the United States. Thailand and Vietnam demonstrate a mixture of standards across these 4 main standard setting bodies, but only Thailand was found to reference these ANSI or IEEE standards as mandatory. 4 of the 59 standard families that we looked at were found to be accepted in all 5 countries. You can see those listed there, and an additional 2 were validated in 4 of the 5. The the bottom line conclusion on this was that the IEC standards were the predominant standards utilized in the countries that we looked at as part of this study. Next slide, please. So from this, the research concluded that there may be opportunities for adopting some emerging standards, we'll call them, to supplement or augment those that were currently in place. And as you can see here, most of these are concerned with the interconnection or integration of DERs onto the grid. Again, this is critically important with the great deal of innovation that's taking place from customer end use applications, as well as from manufacturers, that the new equipment be able to effectively communicate and provide services to the grid in addition to the customer benefits. These will be, we think, increasingly important as adoption increases in these countries, and we're looking at a much different scale of technology integration than really any other period in history. So these five in particular, I won't go into detail on them, but we thought these would be ones applicable in these countries to look at to help drive that future adoption and integration of DERs. You want to go to the next slide. It notes the dynamic that I referenced earlier, but just showing the rate of electricity consumption in these five countries over roughly the last decade. You know, we do a lot of research in North America. These rates of consumption are much different, much higher, and speak to the economic development that's ongoing and the critical role of electricity in providing the energy for that economic development. So it's critical as new technologies integrated that it continue to provide that reliable resource to this economic growth. And you can see there on the rightmost column how much of a increase that growth is attributable to wind and solar PV generation. Some incredible rates of growth there over the 3-year period that we looked at. We know that much of the future generation that will satisfy this incredible rate of growth will come from renewable resources. So again, it speaks to, we think, the importance of working out what the standards will be to integrate these technologies. We want to turn to the next slide, which I believe is the last slide. We'll just leave you with a couple references to these standards and applications that we think might have some relevance. Again, focused in a couple areas. With the increase of distributed PV, the role of advanced inverters becomes critical. Again, as more of the resource becomes inverter-based, the need to control this and effectively optimize it is important. Again, particularly when you think about the climate resiliency and weather events that impact how inverter resources interact on the grid in distinction to more traditional baseload resources. Part of that opportunity is around demand response. This we found to be very early in its application in these countries, but we think that particularly with the increase of customer-cited, locally cited resources, that the opportunity to provide demand response may be there. We've heard this as a potential for electric vehicles if effectively integrated at scale on the grid, but also things like smart thermostats and home automation, industrial automation technologies that could, again, if effectively communicating with the grid, provide a demand response resource when needed. And part of that also relies on the ability to monitor and meter electricity effectively, which is the last one we note there. So thank you for the opportunity to share a bit about the study. Happy to address more in the Q&A later. Thank you.
Thank you, Dan. I see lots of hard work ahead of us to get interoperability optimized, but it's fantastic how you've highlighted the opportunities there on the specific issues. Our final speaker for today, before we reconvene for our Q&A session, when we gather all of the companies together, is Douglas Duncan, Senior Manager for Strategic Development at Durapower Asia. Douglas, the floor is yours.
Thank you, Christian. Good morning, good evening. It's a pleasure to be here. It's a pleasure to listening to my colleagues here in the panel. Very interesting information. I'm learning a lot. And I hope that I can add to this, talking a little bit about batteries and battery systems. Next slide, please. Just a little bit about me. I'm originally from Belgium. And as luck would be, I started my career in Detroit, working on nickel metal hydride battery systems for the American automotive industry. The world has changed very much since then. The technology has advanced tremendously. The costs have gone down, and the acceptance is much further along than it was at the time. So it's exciting to be part of these industries. It's exciting to be back, and we look forward to doing our parts to support sustainability efforts and electromobility. Next, please. So who is Durapower? We are a Singaporean company. We specialize in the design and manufacturing of lithium battery cells and systems, and we cater for such industries as electrical vehicle, marine applications, specialty applications, and stationary applications. Next, please. We are located in Singapore. We also have operations in China, in Thailand, in Holland. And you can see our products are being distributed around the world, specifically in Southeast Asia, China and Europe, and even the US. Next slide, please. We specialize in, sorry, could you go back one, please? We specialize in nickel manganese cobalt and lithium iron phosphate, which are two of the most commercially mature technologies for lithium ion family of batteries. We also provide lithium manganese iron phosphate, a new chemistry. We are working hard to develop some new components and some new materials like titanium dioxide for improved performance in hot climate applications, and non-flammable electrolytes to improve the safety of our batteries. We're also looking at newer technologies like solid-state batteries, which we believe will make a very big difference in the future. But today, really focusing on nickel manganese cobalt and lithium iron phosphate for vehicle and stationary applications. Next slide, please. As a Singaporean company, as a pioneer of energy storage solutions, we believe it's our responsibility to develop capability in Singapore and to support the ecosystem. So we do this through partnerships with the government agencies as well as the universities here in Singapore. And maybe you can click a little bit, a couple of times, please. And we do this through joint projects. So we do projects on material research, we do projects on new types of batteries and prototyping, as well on system level and vehicle level pilots and demonstrators. Next slide, please. Our focus is on larger battery systems. So we're not involved in consumer electronics. We start at 5 to 10 kilowatt hour and look at the space between that and the multi-megawatt hour level, which represent the large stationary utility scale applications. Next slide, please. We group our opportunities in 4 segments. The first one is vehicle platforms or e-mobility, where Durapower has a strong track record and experience with heavy-duty vehicles, in particular buses, trucks, but also with passenger cars, 2-wheelers and 3-wheelers. The second segment would be specialty platform for vehicle like autonomous guided vehicles, like mining trucks and construction vehicles. The third segment is for marine applications, hybrid and electric vessels. And the last segment would be for stationary applications, residential, microgrid, and utility scale. So you could say we're quite diversified. Next slide, please. So let me talk about a few of our areas of activities. The bus segment, I would say, is one of the most important one to Durapower. Over the years, we have supplied more than 1,000 systems to bus OEMs in Europe, in China, and in the region. And we have provided high power and high energy battery systems to electrify these fleets with a perfect safety track record. Next slide, please. We also do a lot of work. Previous slide, please. We also do a lot. No, previous twice. One more slide back, please. Thank you. We also do a lot of work with harbors and specifically autonomous guided vehicles. As you can see, this yellow truck is autonomous. It doesn't have a pilot. It carries containers between vessels and storage areas, and it functions purely on high-power batteries. They use high-power batteries because it allows them to operate for long periods of time and to charge in a 15 to 20-minute period at high-power chargers of 450 kilowatts DC. We supply these types of systems to our OEMs and to our customers in places like Singapore, as well as in Holland. Next slide, please. We're also entering the marine segment. Our first opportunity to do so was in Singapore with this green hybrid vessel, which was a collaboration with Penguin, Boss Marine, and Danfoss Editron, and for which we took one of our packs through full marine certification. Next slide, please. At the same time, we designed systems for one pack. Thank you. We designed systems for full electric ferries operating in Thailand. The one on the left with our partner Bamboo Next is now operating in Phuket. And the one on the right is operating in Bangkok River as a water taxi. Next slide, please. In Singapore, we also provide chargers. It makes sense for us to offer that product and that service to our customers because we have strong relationship with vehicle OEMs as well as fleet owners. So we've taken some of the models that you can see here that are collaboration products with some of our European partners, and we're taking them through TR25 certification, which is a certification for Singapore, and we are basically installing these in public locations with our customers, such as SP Group, the main transmission and distribution company in Singapore. Next slide, please. Thank you. Then, of course, there's the stationary segment, right? And in stationary, on one side, you have microgrids and off-grids, and on the other side, you have on-grid and utility scale and the likes. So Durapower has done a number of projects here in Singapore for microgrid applications, like on Semakau Island or on Pulau Ubin Islands, where there is no connection to the national grid, but also in other countries like Myanmar and Indonesia, where our batteries can be used to support telecom tower and other types of required microgrids. Thank you. Next slide. We're also entering the residential segment. This is something that is very common, I would say, in Europe and I think developing in the US. It's newer to this part of the world, but the ability to add flexibility and storage in your own home to either support your car charger or to store your own rooftop electricity is becoming more and more interesting. So we are also a player in this segment. Next slide, please. Finally, we look at the containerized solution. Battery systems are a way to add flexibility in the grid, whether on the demand side or on the supply side. And if they're designed in a modular way, they can be leveraged to enable solar applications or wind applications to reduce intermittency, but also to offer grid services like peak shaving, load shifting, frequency regulations, and the likes. Thank you. Next slide. For this segment, we offer LFP solutions as well as NMC solutions. LFP is a proven chemistry that offers good value for money and is demonstrated as a very strong chemistry for stationary applications, especially in this part of the world. Next slide, please. NMC is known for its high power and high energy density capabilities. So it can pack more energy in the same space, and it can deliver higher power for certain applications that require it, like frequency regulations or black stars. So we also offer those types of solutions. Next slide, please. Here is an example of an installation that we did here in Singapore. This is a NMC battery that's combined with the PCS, all in a container to support a virtual power plant application. Next slide. Thank you. Throughout Durapower, we believe in the circular economy. I think sustainability requires that every industry looks upon itself and tries to improve the way that products are being manufactured and the green aspects of components and processes. So it's very important for us to look at the whole value chain of battery and see what we can do to improve on that level. So we are a full-fledged cell manufacturer. We do our own slurry, we do our own cells, our modules and our systems. We deliver those solutions into vehicle and stationary applications. And there is an additional opportunity to extend the values of batteries by looking at redeploying end-of-life packs from the vehicle world into the stationary world. This is an application that's called Second Life, and it's really useful to lower the total cost of ownership of battery systems and also to take a full advantage of a complex product. Finally, of course, recycling is extremely important in our industry, so it's important to ensure that all of our products are recycled properly. Next slide, please. Just to demonstrate the point on Second Life deployment, the concept really is after first life to inspect the battery packs and assess their state of health. If the state of health is sufficient to move into a Second Life redeployment, let's say a solar applications, it can be done so without any manipulation or without any remanufacturing. Otherwise, the pack have to be opened, the modules and the cells may have to be inspected. And at that point, the decision is made between either refurbishing or recycling. Next slide, please. Durapower has done a few pilots of this Second Life deployments, one of which is shown here. We've worked with our partner VDL, a Dutch bus manufacturer, to showcase how their end-of-life packs can be moved into this blue cabinet at the bus depot to support the charging of the bus, therefore really adding value to the bus operator for the full life of the battery product. Next slide, please. We also do this with PSA here in Singapore. PSA is the Port Singapore Authority. It is a very important harbor operator operating in more than 16 harbors around the world. And they have very, very ambitious electrification plans that include quite a number of electric autonomous guided vehicles, these trucks that we talked about earlier. So it makes sense for them to want to look at using these battery assets from the vehicle world and to leverage this to support their private grid and potentially, eventually, to support the national grid and add an additional revenue stream for these batteries. Next slide, please. That's it for my presentation. I'm quite happy to answer any questions. Thank you for the opportunity.
Great, thanks so much, Douglas. Wow, that was some really innovative applications there across the board. Really appreciate all those examples. And frankly, I'd love to learn more about some of the lessons learned from implementing your projects across the region. But first, let us just get a moment here to get set up for the second portion of today's event, which is our roundtable. I see that our organizers have set us up in this super awesome, convenient manner. So just as a reminder to our audience members who I know you're out there and you can hear me, but I can't hear you. So if you would just take a moment to look at the Q&A panel, that the window that you have on the bottom right of your window through the Think Roundtables platform, please feel free to ask Q&A and we'll get to it. But in the meantime, of course, we've got some Q&A that's prepared ahead of time. So we'll just jump right into that right now. Again, thanks to all of our presenters for this really great technical presentations. There really is so much you can dive into in terms of innovation and energy, right? These are giant catchphrases. But of course, for a lot of what we're doing, the key focus is climate change issues. And so I'm curious, as we look at more of these low carbon technologies, but would each of you be able to maybe highlight something that you were doing, maybe especially pre-pandemic? Because I know that when we talk to companies, right, everything during the last year has been a little bit difficult. So even if you have to reach back a little bit to that pre-pandemic time to say, what were you doing? And maybe perhaps how it's different, what's happening now. If there's a different focus on that, we'd happy to hear that too. So floor is open, gentlemen.
Maybe I'll get us started. Thank you, Christian, for this question. I think that I think that having worked with customers around the world, the focus on sustainability and the focus on the green aspects of our process and our product has been quite important for a long time, but never has it become more important today to start looking at your process, start counting the carbon that is being produced, and starting to really kind of make those kind of calculations to understand what is the impact and the footprint of your own product. So not only does our product make a difference in these applications, but I think we also have to be responsible for the manufacturing process. All right. So this is something that's very important to us. I think there are a lot of opportunities today to track those types of data, to improve on the use of water and gas and electricity and renewables, and to try to make your process more efficient, so that the end product truly is more sustainable.
Thanks, Douglas.
I'll share that. I'll share that from an electric utility perspective, resource adequacy is increasingly a topic of focus. We know that the decarbonization of the electricity sector is occurring, and it's going to continue to occur and accelerate. But with this, the need to provide reliable, affordable electricity doesn't go away. And I think certainly in North America, we saw a number of instances of extreme weather and climate events changing expectations about just how resilient the grid needed to be, particularly in California with wildfire, and then recently in Texas with the extreme cold temperatures. So it points out the integration of the energy system, not just electricity, but all forms of energy, and the need to plan around providing adequate resource while decarbonizing. So I think for utilities, this is increasingly a challenge. I know in Europe, as they continue their path of decarbonization, they're seeing just the changes that it requires in operations. With the impact of the pandemic, certainly a shift in consumption. We saw that quite clearly with the restrictions put in place around movement and how that shifted consumption. Some of these will be lasting effects, lasting changes in consumption, as obviously work modes and other modes have changed. So the nature of where the energy needs to be and when and how the demand is shaped is different now after the pandemic. But again, the need to provide that resiliency and reliability of the system hasn't gone away. So we foresee that'll be a continued area of focus, particularly as you talk about all these new technologies and capabilities being added to the grid. How do you make sure from a planning standpoint you're still able to meet the need through some incredibly challenging conditions that might arise?
Yeah, building up on that, obviously the resilience of the grid becomes a big issue on these times where consumption has changed. Restrictions of movement have completely changed the center of consumption, and we are seeing more and more requirement for distributed power in opposition to centralized power stations. And time to power can become a critical element, especially to deploy new capacity in areas that are suffering a lack of capacity. And that's what we've seen, I would say, at Bloom. The pandemic itself did not touch our development at all. We've expanded internationally right in the middle of it. And we see an overall high level of consciousness and a big development of the consciousness of carbon footprint, whether those are big blue chip companies or even small shops. Everybody is starting to have a big concern on their footprint and planning to act on it, or already acting on it, and providing sustainable solutions to reduce carbon footprint for utilities, but also for industry is really the way forward for us.
Great. Thanks, Ben. Appreciate that too. Maybe just working off of that, and I know like really a lot of the presentations, it's great flavor all across the board, a nice mixture of some of the different work going on in this space. And I know some of you definitely focus a little bit more on the applications aspect of your work, but I'm curious a little bit, and I'm biased, of course, as a government employee, talk about some special public-private projects. And I know, Douglas, you mentioned several, right? You just sort of rattled a lot, especially here in Singapore. And I think that definitely speaks to the very close relationship that Singapore has with private sector here. But if you would, and maybe speaking to some of the other speakers here as well, if there are any other projects that you think would be relevant to highlight that your organization has done, and maybe any lessons learned also for our speakers and also for our policymakers that are on the line, that could be helpful.
Thank you for this question, Christian. I think that that the Singapore government, the government agencies, are putting a lot of effort forward to support local companies, to drive innovation, and to push the boundaries within certain segments. Some of the work that we've done has been strongly enabled by agencies like Enterprise Singapore and EMA. In some of the work that we've done at PSA, or some of the work that we will be doing for the MPA SMI project, which will deliver an electrified vessel in a couple of years. So there's a number of projects that have been enabled by the government agencies that have forced or encouraged, I would say, companies to work together as consortiums with the IHLs and with the universities here to develop some best-in-class new innovative solutions to problems that the government has, or to potential opportunities to reduce carbon and to demonstrate new types of networks or technologies. So we're very thankful for the support of the government. We're very thankful for the support of the agencies, and we look forward to many more projects with them.
Yeah, I'll just share in relation to the question. It's something that's very important to EPRI. It goes back to our founding. Just by context, EPRI was formed after a blackout in 1965 in the U.S. that put 30 million people out of power. And it was the federal government with utility operators coming together to say we need R&D that ensures the reliability and resiliency of our grid. So that's at the very core of EPRI and has continued throughout our work. It's because there's so many different projects going on, it's a bit hazardous for me to highlight one in particular, but I'd say around the decarbonization area, it's particularly critical. A couple areas of low carbon resources initiative that EPRI has ongoing, which is really looking to leverage the opportunities in hydrogen, but again, link it back to the work that's already ongoing in other parts of the energy system. From a policy standpoint, we know that decarbonization is being driven through policy in so many different forms around the world, but the technology capability to achieve those policy outcomes have to come from an incredibly complex and diverse set of suppliers and stakeholders working together. So I think an area of particular focus for us is helping to think through what that energy system looks like. What is the interconnection of all these resources look like to achieve those societal aims around decarbonization? Particularly exciting, I think, is when you think about the decarbonization of other parts of the economy besides the electricity sector. We're seeing obviously in transport that now seeming to accelerate. So with that, again, comes great opportunity for decarbonization, but also potentials that have been discussed that hopefully can soon be achieved around what electric fleet can do, not just for moving people, but also perhaps providing resiliency or other benefits to the grid. So I would say that a lot of the point is around the increased complexity, and in order to make a way through that complexity, it's going to take a lot of different stakeholders working together to achieve what that future is going to look like.
As a public-private kind of partnership project, I can share the use case of the city of Hartford in Connecticut, in the US, that was suffering for yearly outages and preventing a lot of the activities in the city center to happen. Bloom and partnership with Constellation, the EPC contractor, we developed a very unique, complex microgrid to power the entirety of the city center, such as the elementary school, the library, the senior center, and the health center via 800 kilowatt fuel cell system that was deployed, and that is providing electricity below market rate to that city, ensuring continuous service for the citizens of the city. So that demonstrates as well how city and municipalities are looking after building up resiliency in the city, but also creating a path to reducing carbon footprint and providing sustainability to the citizens.
Thank you guys all for those answers. Those are really clear-cut examples. Really appreciate that. So we've got some questions that are coming in, so that's great. Please keep them coming. We have probably still another, let's say, less than 15 minutes or so. We can keep our roundtable going before we conclude here. So one of the questions here, I think, Douglas, you started to touch on this, but feel free, we can maybe engage that conversation a little bit further. It's and maybe not just Singapore specific. How can companies in the region be incentivized to look at innovation in low carbon energy technologies?
Thank you, Christian, for that question. I think that in many parts of the world, going green, it comes with awareness of where we're heading, right? In the climate crisis and so on. But the importance of the importance of green technology being commercially viable is also one thing to note. And I think in this part of the world, making solar projects, making wind projects viable commercially has been quite important to justify their penetration in the market. Similarly, for battery systems in our industry, it has taken a huge drop in cost so that these systems are starting to see a lot wider penetration and adoption across the region. And I think for the battery industry in particular, we're only starting. I think looking at Bloomberg's data, we will continue to install more and more batteries within vehicles, within marine applications, and stationary applications. And that this takes an enormous amount of effort on cost reduction, on optimization of manufacturing, and the likes. I'll also support my colleague here, Benjamin, to say that there's a lot of opportunities for different technologies. I think batteries are important because they offer flexibility to the system. But at the end of the day, they are energy storage devices. They do not generate any electricity. So it is very important that we also adopt green ways to generate electricity, and that we adopt things like hydrogen and electrolyzation, renewables as much as possible, so we can green our grids. Thank you.
Thank you, Douglas. And building up, how can we promote carbon reduction? I mean, obviously, some of the governments are implementing carbon tax. They are implementing subsidies and grants and helps. Singapore is a pioneer in the region, in Southeast Asia at least, to put these tools at the disposal of companies who desire to give a chance to innovation, give a chance to product development, to promoting net zero targets and building up on this path to reducing greenhouse gas emissions throughout. So I would say that's a great tool. Now it's all about each and every one of us to have conscious of what needs to be done to reach this Paris Agreement called targets, which are very ambitious. And I think it's a global effort. So government can help, but companies have to be responsible also for what they emit in the atmosphere.
Yeah, and what I would add just to the question around incentives, there's certainly societal and other benefits that should incent companies and governments to move in this direction. But if you look just at the financial benefits, I'm not that old, but I'm old enough to remember a time in the industry when discussion of renewables was always accompanied by a discussion of how much more they cost than traditional resources. And that is no longer the case in many regions and many applications. So for utilities who adopt least cost planning methodologies, we're already seeing that because of the manufacturing technology advances, a lot of these technologies and resources are the least cost alternative. And so I think that trend will continue. Those financial benefits will flow through to customers. And now we see companies independently contracting for renewables, storage, resiliency, because they see the financial benefits of doing so. I think increasingly too, looking at the other benefits around resiliency or flexibility of operations and what those might achieve for companies is really important. It's not just cost in relation to other resources, but what are resiliency or other benefits that might be achieved by adopting some of these resources. So I think that will continue, and I think not much adoption will occur because over time these will become the most competitive resources for folks to use to supply their energy needs.
Great, wonderful. I'm worried we're going to run out of time, so I'll just start to maybe hammer through some of the questions because we've got some really good ones here. Maybe this one could be a little bit more directed to Ben, since you did mention the potential of taking some of the byproducts from nuclear energy generation. Given that several ASEAN countries have indicated that nuclear energy will be part of their energy transition, will we, sort of in the U.S. ASEAN Innovation Forum, include a discourse on nuclear innovations such as SMRs, or small modular reactors? Just curious on your opinion on that. Just doesn't have to be a full academic answer, but curious of if you've done any sort of research on this area here.
Well, Christian, I mean, nuclear for us is new as a form of partnership with this national Haideo. It certainly has tremendous benefits for us in terms of steady source of power and low carbon power, and using that power when the power plant produces an excess compared to the grid needs. And combining that with the excess of steam, which is also produced in a nuclear power plant, will definitely be a great sources for us to feed our electrolyzer and produce hydrogen. So by all means, those small nuclear reactors that could be deployed in the region, I don't think it will be done overnight, but it could also be part of the energy mix that could make sense, especially if they can be deployed on floating solutions here and there, where power requirements in scattered location. I'm thinking about Indonesia, I'm thinking about the Philippines, for example, with remote location need for decent, sustainable and affordable power.
Great. Douglas or Dan, just throw that to you as well if you want to respond, please.
Well, I would say it should be part of the conversation at every, research on SMRs has been ongoing for a long time and will continue. So it's, I think, important. The possibility of an integrated energy system is exciting as this new technology is adopted. So the more options we have, it will be regionally distinct, but the more options available, I think, the better.
Yeah, I agree to both Benjamin and Dan. I think nuclear is a technology that has been proven to a certain extent, but of course there are some safety issues or potential safety issues and some political issues. So I think it becomes more of a decision of where it is located and how do we ensure that this is done in the right way. But every generation has its advantages and its disadvantages. I think moving forward and looking at distributed energy resources, we have to be smart about it and benefit and leverage each technology at the best of its efficiency.
Well said. Maybe another one that's a little bit more about the U.S. ASEAN partnership and sort of you think through this both as ASEAN-based as well as U.S.-based organizations. I'd look forward to hearing your thoughts on this. How could the U.S. and ASEAN partnership be further enhanced to drive innovation? Be a little more of a policy wonky question, I'll admit that. So if we don't have any takers in the next 10 seconds or so, I will move on.
I might just jump in just to say that these types of events that we're doing right now really do help to create awareness of what is being done in one region and the other region. I think that every region is different. Every economical and geographical situation is different, but at the same time, we have a lot of similar issues, ecological and the likes, and it's important to benefit from the lessons learned from different regions. For our industry, I would say that the U.S. has been a more mature and a more pioneer for large-scale ESS solution. And I think we enjoy from their experience, and we try to gain from what has been done over there and the ways that we can make it work.
Yeah, what I would say, I don't want to, make any implication about this not occurring today, but, for someone that focuses on innovation day in, day out, I think it's always, for me, about more demonstrations, more scaled deployments. Let's get things commissioned. Let's get things in operation. I think that's the way to learn. That's the way to improve technology integration. So in the early applications, that requires a lot of partnership among stakeholders, because there may be a resistance to be the first or to be in the early going. But I think that's so important that to the continued innovation that we need to continue to see deployments and actual operating experience so that we can refine, how we're integrating this technology.
That's great. I've got one maybe to leave on an interesting note. So the question is, do you think that the technology needed to reach net zero climate change goals already exist? You got to keep it interesting, right? I mean, we've got some people that are up late at night, so let's talk about it.
It's a great question. I think yes, but the complexity it gets ever more increasing as you get to that net zero target. So we hear a lot about the challenge of 80 to 100 or 90 to 100 and what exists there. So I don't think it's solved by any means, but I do think the technology exists today. And I think where we're seeing in those regions that have higher penetration of renewables, that they're tackling the problems as they occur. So I think we just have to keep on pace in that direction. But I think we have the tools to get there.
I would join Dan in that, saying that I also think that most of the technology is there. We might find new ones, but I'd say today it's more about finding a mix of the different technologies available. And the biggest challenge is rather on the economics than on finding new technology that will reduce the carbon footprint of industrial. It's about finding a balance on how much premium you want to pay for decarbonizing your industry, your country, or your society.
Yeah, I agree with Dan and Ben. I think the moving forward will definitely depend on a mix of technologies for generation, for storage, for mobility, and we will continue to improve all of these areas. But I think the basis is already there. I think we just need to push forward. The hardest part will be to build new business models, new political models, new habits as personal aspects to affect real change. Right. So it's not just about the technology; it's also about what we do every day. But I'm very hopeful, and I look forward to seeing what happens in the next decade. Thank you.
That's great, gentlemen. Well, I'm feeling inspired, and also notable the fact that we may be concluding near on time. So thanks so much for not only your technical presentations, but for this engaging conversation. Again, thanks also to our audience for the engaging questions. And at this point, we'll turn it over to our Deputy Assistant Secretary for Asia, Rich Steffens, for concluding remarks.
Okay, thank you, everyone. And I was glad to be able to attend virtually. Just a couple bulletins. COP26 will begin in Glasgow in a few days, and the international community will be bringing the highest possible ambitions to Glasgow. We urge global partners to join the US in pledging at COP26 to announce a commitment to reduce greenhouse gas emissions between 50 and 52% by the year 2030. We urge the business communities to step up to be an active part of the solution, such as through setting public targets for operations, in line with the goal of limiting warming to 1.5 degrees. And we welcome opportunities to work together with all of you to further these objectives. Thank you for the excellent panel discussion today and the excellent questions. Look forward to working with all of you on clean tech projects.